February 1942. An ordinary, peaceful day. A Mexican farmer named Dionisio Pulido was working in his cornfield as usual. Everything seemed normal, and there was no sign of danger. Suddenly, a strange rumbling sound echoed through the air. Startled, he looked up at the sky. The sky was perfectly clear, without a single cloud, yet the rumbling kept growing louder. The sound was not coming from above. It was coming from deep beneath his field. Within moments, the ground in the middle of his field split open, forming a huge, deep crack from which poisonous black smoke began to rise. At the same time, blazing hot rocks were hurled into the air. Helplessly, the farmer watched as a new mountain began to emerge before his eyes. This was the birth of Paricutin, a brand new volcano. For the next 9 years, this crack continued to spew fire and ash. The eruption produced so much lava and volcanic material that it buried nearly 200 square kilometers beneath it. But where did this new volcano come from? And what force was responsible for such a terrifying eruption? To answer that question, we must journey deep into the Earth's hidden secrets. The ground we walk on seems solid and calm. This outer layer is called the Earth's crust. However, the crust is only the thinnest layer of our planet. Beneath this seemingly peaceful surface lies an entirely different world, known as the mantle, a realm of darkness, immense pressure, and temperatures that can reach 1,000 degrees Celsius, 1,832 degrees Fahrenheit. Because of this extreme heat, the mantle's solid rocks begin to melt. These molten rocks form a thick, boiling substance called magma. Every volcanic disaster begins with magma. The Earth's outer shell is not one single solid piece. Instead, it's made up of enormous puzzle-like sections called lithospheric plates. These plates are constantly moving, although at a speed as slow as the growth of human nails. When these massive plates collide or grind against one another, large cracks can form in the Earth's surface. In some places, particularly beneath the oceans where plates move apart, deeper rocks melt more easily, creating pathways for magma to rise. In other places, when an oceanic plate sinks beneath a thicker plate, it drags vast amounts of seawater deep into the earth. This water lowers the melting point of rocks, causing even more magma to form. Since magma is lighter than the surrounding solid rock, it naturally rises upward. It accumulates in underground chambers known as magma chambers. Inside the Earth, a constant battle takes place between three powerful forces. One is lithostatic pressure, the enormous weight of the Earth's crust pressing downward. Two is magmastatic pressure, the upward force exerted by the magma. And three is rock strength, the natural strength of the surrounding rocks. As long as these forces remain balanced, the Earth stays calm and the magma remains trapped underground. A simple way to understand this is to imagine a pressure cooker. As water inside heats up, it turns into steam and builds pressure. The cooker's valve slowly releases this pressure. But if the valve becomes blocked, pressure continues to build until the cooker explodes. Volcanoes act like the Earth's pressure relief valves. So what causes this delicate balance to break? One major reason lies within the magma itself. Magma contains dissolved gases such as water vapor and sulfur compounds. As magma rises and cools slightly, minerals begin forming crystals. This process forces the dissolved gases out of the magma, creating high-pressure gas bubbles. These bubbles make the magma lighter and more buoyant, much like shaking a bottle of soda. When billions of these bubbles reach the surface together, they burst with tremendous force, sending ash clouds high into the atmosphere. Scientists believe this process was responsible for the eruption of Paricutin. Sometimes eruptions occur because of a process called unloading. This happens when a massive landslide removes a large portion of a mountain. With the weight suddenly gone, the underlying magma can rapidly expand and erupt. The catastrophic 1980 eruption of Mount St. Helens was triggered in this way. In other cases, acidic magma and extremely hot gases gradually weaken surrounding rocks, transforming them into soft clay-like material. Eventually, the rocks can no longer contain the pressure, and the magma breaks free. Not all volcanoes erupt in the same way. The style of an eruption depends largely on the type of magma involved. If the magma is thin and fluid, it flows gently through cracks in the ground. The shield volcanoes of Hawaii often erupt this way, producing spectacular lava fountains that can continue for days. The real danger comes when magma is thick and sticky. Such magma traps gases inside, causing pressure to build to extreme levels. When that pressure finally breaks through the crust, it creates a violent explosion known as a Plinian eruption. Ash, gas, and rock can be blasted more than 50 kilometers, 31 miles into the sky. The eruption of Mount Vesuvius in 79 AD was a classic example of this type of devastating eruption. If seawater enters cracks and comes into contact with extremely hot magma, it can instantly flash into steam. This rapid expansion dramatically increases the power of the explosion, making it even more destructive. Today, scientists use advanced technology to monitor volcanoes. Thermal cameras measure underground heat, gas sensors analyze volcanic emissions, and lasers detect subtle changes in a volcano's shape. Yet despite all this technology, accurately predicting exactly when a volcano will erupt remains extremely difficult. Magma chambers lie so deep underground that measuring their internal pressure precisely is still beyond our capabilities. Volcanoes are not merely mountains. They are the Earth's breath, its pressure valves, and sometimes its fury. When a volcano is preparing to erupt, there is often only one reliable survival strategy: get as far away as possible. Because when the Earth tears open its own surface, there is no force powerful to stop it. The next time you see a mountain standing silently on the horizon, remember, beneath it could be a river of molten rock waiting for the perfect moment to break free. Volcanoes remind us that our planet is alive, constantly changing, and far more powerful than we often realize. If you enjoyed this fascinating journey into the hidden forces of Earth, make sure to subscribe to Top Facts English for more incredible stories, mind-blowing facts, and mysteries from science, history, and nature. Don't forget to like, share, and subscribe, and tell us in the comments, which natural disaster do you find the most terrifying? Volcanoes, earthquakes, or tsunamis? See you in the next amazing fact.